Welcome to the Calculus B section. In this section, we'll be discussing integration by parts. So, integration by parts starts off with a new formula that we have not seen before. We have our u dv equals uv minus the integral of v du. So all of this is pretty foreign to you except the u's and the du's. So essentially, integration by parts says that you're going to be starting off with one integral, the left side of the equal sign, and calling one part of it u, which is our u substitution that we had in prior, and the other part v. So v is going to be our second integral, our second substitution. So the second substitution is going to help us create an extremely convoluted integral into something that is seemingly doable. So in prior for u, we didn't have any guidelines for figuring out what our u would be, just based off of commonality. But here for integrating by parts, we want to select u and dv with the according standards. So we have something called LIATE, or light, as people like to call it, which means that our logarithmic functions are going to come first. Our inverse functions are going to come second. Our algebraic functions will come third. Our trig functions will come fourth, and our exponential functions will come last. So what this means is that when you are selecting between u and dv, because the way it works is you say u equals and du equals because you derive it, and then you say v equals and dv equals. So essentially what you're going to be doing is you're going to be selecting a u first, and you're going to be selecting a dv. So based on whichever comes first, that will be your u, and whatever is second will be your dv. So in order to get your v, you'll integrate this value and put it here, and as prior we stated that when you have your u, you will take the derivative and place it here. So let's try out a problem. Let's say that we wanted to take the integral of x cubed ln x dx, okay? So since ln x is a logarithmic function and x cubed is an algebraic function, we're going to say that u is equal to x, oh, my apologies, ln x, oops, x cubed ln x dx. So we're going to say that u, since u ln x is equal to a logarithmic function, is going to be ln x, and du is going to be equal to 1x dx, or commonly written as dx over x. Okay. So now we know that our v is equal to and dv is equal to, because we're going to select dv. dv is going to be equal to x cubed. Okay? And that means that our v is going to equal x to the fourth over 4. So now we have our original equation. We know that the integral of u dv is equal to uv minus the integral of v du. So we're going to do a couple of substitutions here, and we're going to say, so we know that the integral of u dv is equal to uv minus the integral of v du. Therefore, we have the integral of ln x cubed is equal to u times v, which is going to be ln x times x to the fourth over 4, minus the integral of x to the fourth over 4 of du, which is going to be 1 over x. So we can simplify this and state that the integral of ln x cubed is equal to ln x to the fourth over 4, and then minus the integral of x cubed, because if we put, x cubed over 4, my apologies, because if we were to multiply the denominator by x, we can just subtract or cancel out. Okay, so now that we have this simplification, we are just dealing with the right-hand side in order to find our integral of the ln x cubed. So we know that ln x to the x to the fourth over 4 minus x cubed over 4 is what we're dealing with. So we want to say that the integral of that is actually equal to x to the 4th over 16, and that is going to be plus c. So that means that our integral of the function ln x cubed is equal to ln x to the 4th over 4 minus x to the 4th over 16 plus c. And that's it. That's our integration by parts. So if you need more help or additional assistance, there's a bunch on the website, and I hope that helps.